Hey everybody, welcome back. Today is the 23rd of October, and I'm solving Leetcode 2641 Cousins in a Binary Tree, Part 2. Uh, Given the root of a binary tree, replace the value of each node in the tree with sum of all of its cousins' value. Two nodes of a binary tree are cousins if they have the same depth, which just means they're on the same level and with different parents. All right. Return the root of the modified tree. Note that the depth of a node is the number of edges in the path from the root node to it. All right. Yeah, so that makes sense. Hmm. Let's just look at an example here. This would become 0, 0, 0. This is 7, and then that is 11. Let's look at the explanation. Hmm, root the node with value 5 does not have any cousins, so its sum is 0. Node with value 4 does not have any cousins, so it's 0. Similarly for 9, value 1 has a cousin with value 7. Okay, so this is node 1 here, and it has a cousin with value 7. All right, so which just means that they're on the same level. So you can see 1, 10, and 7 are on the same level. But since 7 has a different parent compared to 1, it would be considered, they're considered cousins. And then if you think about 1 and 10, well, they come from the same parent, so they would be considered siblings. All right. So we are supposed to sum up whatever cousins the nodes have on that level and then change the value for them in that particular node. So if you look at 7 here, uh, node 7 has cousins with values 1 and 10. So you sum them up and return it as 11. And that is what we're seeing in the final tree here. Okay. And then example 2 is also, I mean, example 2, you just have a root. So the first node is always going to be 0. And then on level 1, uh, it's a right child and a left child. These two nodes are siblings. They do not have any cousins. So your resultant would be a 0 as well. Okay. Let me pull out my iPad really quick and let's see if I can visualize this a little better for you guys. So, what comes to my mind when I think about this question is something similar to what I did yesterday. Yesterday, we had a question related to level sums. So, which is basically if you look at this tree right here, you would sum up all the nodes on the same level. So this is level 1, this would be your level 2, and then similarly this would be your level 3. You would sum them all up. So on level 1, you just have one node, so you sum it up and you get 5. You sum them up here, you get 4 plus 9, that's 13. And then here you get 7 plus 1, that's 11 plus 7, 18. All right. So we see this. Cool. And how do we reach from this point to this point now? So what I figured out was you could maintain two integers every time you're going down a tree. So I mean, uh, just figuring out the level sum itself. This is we could do this by BFS, a breadth first search, and we could store all these sums on the same level in an array. So you could have at the end your array would look something like that. And how would you come to this final tree right here? Um, the way you would come to the final tree right here can be given by a formula. If you just look at it closely, it's just this formula makes sense to me. You would do your level sum, which is these values right here, and then you subtract the sibling sums from it, and then that would give you your cousin sum value. So just like yesterday, we need a function that would be called recursively to store all your level sum values. So this I'll just call it rec. We would need an array list, which is just a dynamic data structure here. It's easier to deal with. Um, let's just call it R. You would need your current level that you're on, and you would need um, what else would you need here? You would need the node that you're on. So like which tree node you're on, we'll just call it node, and that should be it. Let's just initialize an array list here as well. Integer. Uh, Also call it R. Doesn't matter. Array list. That's fine. And now let's begin. So now, if you're traveling in a BFS sort of way, um, if your node is equal to the null, you just return, you come out of it, you go back up one level. And then if you reach a new level, so if your level is equal to array dot size, uh, you would just array dot add, and you will initialize the value with 0. All right. What else would we need? We need the sum, right? Yeah. So array dot set, we need it on that level, and then it would be array dot get level, and then plus node dot val. Then we would have to recursively call this for left and right child. So you would have this. This would be the same array. You would just go down one level, and then you would have node dot left, uh, node dot left, yeah, and recursively array level plus one, uh, node dot right, and that should be it. If you guys don't understand how I did this, watch my video from yesterday. I have explained it very clearly over there. If you look at it, you would understand exactly what I'm doing here. All right, so that would be it here. We can just call it. So we would be using our array. We are on level 0 and um, uh, node, right? So we would start from the root. Yeah. Then at the end, I think we're also returning a root. So let me just write that. Cool. This makes sense. Now let's write another function, void change. This is where we're changing. So what would we need here? We will need the array list again, and the array list would contain uh, it would contain the level sum of all the nodes uh, of the level nodes of the tree, and that is important for us. So we need that. We need to figure out what level we are on. We also need the tree node, and this is where it gets different. Now we need another integer, and we're going to call it sib, and this would store the sibling sum of on each level. All right. So how would we go about this? So I think it would be very similar to what we did above. So if your node is equal to null, we just return, and then uh, we need to get the value. We need to set the value, right? Uh, yeah. So node dot val would be equal to array dot uh, get level, and then you would add. Hmm, you would add, we would have to subtract sibling sum from it. That is what we're doing, right? So we need to subtract sibling sum, and then that would give us the correct value here. We would also have to reset sibling sum, sib sum, which is equal to 0. Uh, yep. Is there anything else I have to do? Hmm. Okay. This is fine. If a node is null, we just return. If the value, the actual answer value would just be the level sum value. This is the level sum, and then this is the sibling sum, right? And then we are resetting sibling sum because every time you go down a level, you have to change that value back to 0 again. And now what we need to do is we need to check if node dot left is not equal to null, we would add zip sum plus node dot left dot val, and then if similarly for node dot right not equals null, we would have zip sum uh, plus plus equals here, and then this would be node dot right dot val. Yeah, this would give us the new sibling sum, and then we could pass it on when we call this function also recursively. So we would call it again, we call it change. We're going to give it same name array level plus one, and then this node would be node dot left, and then you would have the new sibling here. And let me just copy this and paste, and then you just do it with right. And then this should be my final answer, I believe. Let me try running it. Incompatible size. Okay, there's a double equals here. Sorry. Mhm. Okay, seems like there's an issue. What seems to be the issue? Oh, I haven't called it here. My bad, guys. So we would need the answer here. Change, and then this would be array with uh, level 0. We're on level 0, and then we're on the root, and we need the root dot val here. Yeah, perfect. That runs. Let's try submitting it. Then I'll pull up my iPad again and explain it to you in step by step exactly what happened. All right, so we got the answer. 33 ms is decent. All right, let me pull out my iPad now.
Alright, let's look at the explanation now. This is our tree. We have a tree here, and we have already calculated using BFS our level sum array, which is just the sum of all the nodes in the same level. So here it would be just 5, here it's 4 plus 9, 13, and 1 plus 10 plus 7, 18. Now let's go back to the second part of the code, which is where we call our change array. We would call this using something like this. We are on level 0, we pass in the root, and we pass in the root dot val. Why do we pass in root dot val? I'll explain when we get down into the code. So the first thing we're checking is if the root is null. Sorry, if the node is null, which in this case it's not because we have a 5 here. If it's not, we change its value. We change it to node dot val equals your level sum. So your level sum on level 0 is just 5, and you subtract the sibling sum, which we have given it by root dot val, and root dot val is also just 5. So you do 5 minus 5, you get 0. At this point, we can change this value here. This would just become 0. And now, since after we have done this, we would now calculate our sibling sum again. So you take a sibling sum, you make it to 0 again, and you calculate. So you check if there is a left, if there is a right, you get these values, and then you add them up here. So you get 4 plus 9, and that would be 13. So our new sibling sum is now 13. We would now call the function again with the same array. You go down one level, so you're on level 1. You do root dot left, and then with the new 13, and then you again do it array level 1 root dot right with 13. This is where we are at the moment. Alright, let me get rid of this, and we will go over what exactly happens when we reach root number 4. Okay. Yeah, so on root number 4, we check again uh, our sibling sum from before was 13, by the way. Yeah, so now we check again if our node is null, which it is not because we have a 4 here. We would change its value, so you get node dot val, which is equal to the level sum on that value, so that is 13 minus whatever the sibling sum is, so that is 0. So this value would now, we can change it to 0, and similarly for this one as well, for 9 it will also become 0. Yeah, and now as you know, we will reset our sibling sum value, so sibling sum becomes 0 again. You check if there is a left, and if there is a right, you add those values and you store them. This would be our new sibling sum, and then when we call the function again, we call it as array. You go down one level, so we are on level 2 now, and then it would be our left child, and then similarly you would do it for your right, and then you would pass in your new sibling sum value as 11. This is what happens. After this point, we can change this. This is now 11. We're on root number, root value 1. So what happens here is you check if this is null or not. Null or not. This is not null, so we can keep going. You change the value. Node.val would become your level sum, which would be 18 here, and minus your sibling sum, which is just 11, and you get the answer as 7. You change your values here, so these two would become 7, and then you calculate your sibling sum again. But at this point it is not important because we know the nodes after this is going to be null, and this condition would become true and we would go back up. So that's how you do it. Similarly, when you reach node number 7 here, this would be node dot val, which would be equals 18 minus 7, which would be 11, and so you would change this value to 11, and that would be your final solution. So you get 0 0 0 7 7 11, and that is your correct answer. Thanks for watching, guys.